Now let's talk about the second and main functionality, spare part criticality assessment. One of the main pain points for our clients is sometimes a spare part is out of stock when it is most needed, and that leads to complete production stop. And as you know, that can lead to a heavy financial losses. Apart from this, it is important to know which spare parts are more important than others so it doesn't lead to heavy inventory carrying costs. To solve both of these problems, we developed this functionality. Let me quickly show you how it works. Let's say I want to assess the criticality of a spare part that is present in one of my plants. So here I can go and directly search the plant for which I want to assess the criticality. Next, I'll select the material for which the assessment is necessary. Here I can select for all the materials, or if you want to assess the criticality for any one or two spare parts, you can do it directly here. As you know, there might be different criticality assessment modules present in the market, such as FMEA model, production impact models, and depending on the company domain, company workings, they can select any of the model that is more relevant to their functionality, and then they simply have to run the assessment. Once AI processing is complete, user can directly go here and see the AI rating defined by the AI. Now for a user it's simply a rating, but they definitely would like to know why a criticality of, let's say, a 4 is given out of 10 for this particular spare part. So all they have to do is simply click here on the AI analysis, and they can get a complete summary of why a criticality rating of 4 is given for this. Apart from this, it has been further broken down into severity, detection, occurrence parameters, and a complete summary for each individual parameter is given to the user as well. So a user has a holistic view of why the criticality for a spare part is given in such a way and why the user should believe it. Today we are going to talk about one of the key important feature of our MRO 360 product, that is our demand forecasting tool. Your traditional demand forecasting tools generally use a statistical model or a rule-based engine to derive the demand forecast. However, our product is an AI native tool that leverages AI to study historical patterns, equipment maintenance history, and current data to derive the demand forecast. So a user will not only get a complete demand forecast for a certain material, but also get a breakdown of preventive versus breakdown work orders in the future. So let's see how it works in reality. So let's say I'm a user and I want to do demand forecasting for certain materials in my plant. All I have to do is go down here and first configure the parameters. So the first parameter is I have to select the duration for which I want to run the demand forecast. So let's say I select 6 months of timeline. Next, I'll select the plant for which I want to run the demand forecast. So I'll select the plant. Next, I'll select the work orders for which I want to run this. Next, I'll select the moment type for which I want to run this. And finally, apply the configuration. The next step is to select the model for which I want to run the demand forecast. So let's say I selected this LLM model. And finally, I'll run this configuration. As you can see here, it has processed the request for all the 60 materials in a short period of time. So now as a user, I would definitely want to get an AI logical reasoning and thinking behind giving this forecast, and also a breakdown of the demand forecast in terms of preventive versus corrective orders. So let's pick up any one of the material. So let's say I pick up this one. As you can see here on the top, you will get an AI summary of why our system thinks this should be your demand forecast for this particular material for the upcoming 6 months. And in the bottom, you get a complete breakdown of preventive as well as corrective work orders in the future.